Though often used interchangeably, flame retardant and flame resistant are not the same thing. The difference between these two terms can be subtle, but it's essential for understanding how materials perform when exposed to fire, and more importantly, how they keep us safe. Hello, my rubber heart. Welcome back to another episode where we break down the fascinating science of rubber and materials. Today we are diving into the world of fire safety. Whether it's for rubber compounds in cables, thermoplastic materials in automotive interiors, or even protective gear, the terms flame retardant and flame resistant come up often. But what do they actually mean? And how are they different? By the end of this episode, you'll have a crystal clear understanding of these terms and how they apply to rubber and thermoplastics industry. Let's start with flame retardant materials. When we say a material is flame retardant, we mean it's been treated with chemicals or additives to make it less flammable. These materials are not inherently resistant to fire. They can still ignite under certain conditions, but the additives they contain slow down how quickly they catch fire, suppress the spread of flames, or help them self-extinguish. The way flame retardants work can vary depending on the type of additive. For instance, halogenated compounds like bromine or chlorine work by releasing gases that interfere with the combustion process. Other additives like aluminum hydroxide or magnesium hydroxide release water vapor when heated, cooling the material and diluting flammable gases. Then there are phosphorus-based compounds which form a char layer on the material surface, insulating it from further burning. Flame-resistant materials, on the other hand, are inherently designed to resist ignition and withstand exposure to flames without the need for chemical additives. Their molecular structure or composition gives them this property naturally. For example, silicone rubber is flame resistant because its inorganic backbone of silicon-oxygen bonds is highly thermally stable and doesn't easily decompose. Similarly, fluoropolymers like PTFE or FKM are incredibly flame resistant due to their strong carbon-fluorine bonds, which can withstand high temperatures and resist combustion. These materials might char or degrade under extreme heat, but they don't ignite or spread flames easily. If they do burn, they tend to self-extinguish quickly. So, what is the key difference? Flame retardant materials rely on additives to enhance their performance, while flame resistant materials are intrinsically fire resistant. The difference matters because flame retardant properties can degrade over time as additives leach out or break down due to the environmental factors like UV exposure or moisture. Flame-resistant materials, however, retain their properties for the long term because their resistance is baked into their chemical structure. Let's bring this into the real world. Think about cables and wires. Many of these use thermoplastic compounds like PVC that are made flame retardant by adding halogenated compounds or aluminum hydroxide. These additives ensure that if a cable overheats or is exposed to a flame, it won't catch fire easily or contribute to flame spread. In critical applications like aircraft or high-speed trains, though, flame-resistant materials are often preferred. Silicone rubber or fluoropolymer-coated wires are used because these materials won't just resist catching fire. They also perform well in extreme heat and don't emit toxic fumes if they degrade. Now, let's talk about processing. Flame-retardant materials, while effective, often come with challenges during manufacturing. Additives like halogenated compounds can release corrosive gases during processing, requiring corrosion-resistant equipment. Others, like aluminum hydroxide, require careful handling because they can affect the material's mechanical properties. In contrast, flame-resistant materials, being inherently fire-resistant, don't rely on such additives, making them easier to process in this regard. Another major factor is regulatory concerns. Halogenated flame retardants, in particular, have come under scrutiny because they can release toxic gases during combustion or processing. This has led to stricter regulations like REACH in Europe and the RoHS directive in electronics, which have driven a push toward halogen-free flame-retardant technologies. Flame-resistant materials such as silicone or fluoropolymers often comply with these regulations more easily because they don't rely on potentially harmful additives. Lastly, let's consider downstream processing. After extrusion or molding, flame-retardant materials often need additional treatment to ensure consistent performance, such as stabilizing the additives or testing for compliance with safety standards. Flame-resistant materials, on the other hand, are more straightforward in this regard. For example, a silicone rubber component can go straight from extrusion to application with minimal additional treatment because its flame resistance is inherent. To sum it up, flame retardant and flame resistant might sound similar, but they represent two very different approaches to fire safety. Flame retardant materials rely on carefully engineered additives to slow down or inhibit fire, while flame-resistant materials are inherently built to resist ignition and flame spread. Understanding this distinction is crucial, especially when selecting materials for applications where fire safety is a concern, whether you are working with thermoplastics, rubber, or composites. I hope this episode clarified the difference between these two important terms. If you enjoyed this deep dive into flame safety in materials, don't forget to like, share, and subscribe to my Rubber Heart. Let me know in the comments what topic you would like to see next. Until next time, stay curious and stay bouncy.